Hello ladies and gentlemen, this is today's question, integral 0 to pi divided by 2, square root of sine x plus 1 and then divided by cosine x plus 1 dx. We're going to discuss solution by Weierstrass substitution. I hope my pronunciation is correct, this is the German name. Meanwhile, some people prefer to call it tangent half angle substitutions. We start by drawing a right triangle, label 90 degree and the angle x divided by 2. Define t equals to tangent x divided by 2. Therefore, the three sides of the triangles are t, 1 and square root of t squared plus 1. We obtain dt over dx equals to 1 over 2 secant square x divided by 2. We know secant square is equals to tangent square plus 1, which means we have dx equals to 2 divided by t squared plus 1 and then dt. So now we have first and second important equation of Weierstrass substitutions. There are another two more important equations for these methods. As this is my first video about this method, give me another minute to derive all four of them. In future, we will directly use the four equations whatever we use Weierstrass substitutions. Based on double angle identity, we know sine x is equals to 2 multiply sine x divided by 2 multiply cosine x divided by 2. From the triangle, we know the values of sine and cos of x divided by 2. So therefore, sine x is equals to 2t divided by t squared plus 1. This is the third important equation. From double angle identity, we know cosine x equals to cosine square x divided by 2 minus sine square x divided by 2, which is equals to 1 minus t square divided by 1 plus t square. This is the last equation we need for Weierstrass substitutions. If possible, remember all of them for future use. Let's see the original question. We actually need square root of sine x plus 1 and square root of cosine x plus 1. Not difficult to find them since we already know what is sine x and cosine x. For square root of sine x plus 1, it is equals to square root of t squared plus 2t plus 1 divided by t squared plus 1. The numerator can be simplified become t plus 1 and then power 2. Meanwhile, for square root of cosine x plus 1, it is equals to square root of 2 divided by t squared plus 1. From definition of t, we can find the integration bounds. When x equals to pi divided by 2, t equals to 1. When x equals to 0, t equals to 0 as well. From here, we can obtain the new q equals to integral 0 to 1, square root of t plus 1 power 2 divided by t squared plus 1, multiply square root of t squared plus 1 divided by 2, multiply 2 divided by t squared plus 1 and then dt. It can be simplified with the constant 2 divided by square root of 2 and the integrands become t plus 1 divided by t squared plus 1. The constant in front can be simplified become square root of 2, while the integrand can be split to two parts. Part number 1 is t divided by t squared plus 1 and part number 2 is 1 over t squared plus 1. To avoid another substitution, we can change the t of the part number 1 become differentiate of t squared plus 1 and then multiply 1 over 2. This is integrable, which is equals to square root of 2 and then multiply 1 over 2 natural log t squared plus 1 plus inverse tangent t. Putting t equals to 1 into the equation and then minus the version that t equals to 0, we know natural log 1 and inverse tangent zeros are equals to 0, while inverse tangent 1 equals to pi divided by 4. That brings us to the conclusion of this video. The final answer is square root of 2 divided by 2 and then multiply natural log 2 plus pi divided by 2. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video with others. I see you in my next video. Bye bye.